26.3 Estimating VO2 max. Introduction. VO2 max is used to determine the level of oxygen someone inhales. Caprito stated that VO2 max refers to the maximal amount of oxygen you can utilize during exercise. It's commonly used to test the aerobic endurance or cardiovascular fitness of athletes before and after a training cycle. For elite athletes, VO2 max is essential as it allows them to perform at a higher level of performance for a longer period of time. This means their fatigue is less, allows them to compete for longer. Athletes want to measure their VO2 max because they need to know how good their cardiovascular endurance is. If the VO2 max levels are low, they would train to improve it to maximize their overall performance levels. Once an athlete reaches their VO2 max, they can no longer exercise at a high intensity as they have reached their maximal oxygen consumption. Absolute VO2 max is simply the maximal rate of oxygen uptake reached at the end of the test and is expressed in liters per minute. Relative VO2 max is milliliters per minute per kilogram, which is expressed as milliliters per kilogram per minute. Maximal tests are VO2 max tests which require the athlete to use up all their aerobic capacity. This refers to the maximal amount of oxygen that an individual can utilize during intense or maximal exercises. This measurement is usually considered the best indicator of cardiovascular fitness and aerobic endurance. The more oxygen a person can use during high-level exercise, the more energy a person can produce. The better the performance, the longer periods of time. Submaximal tests are VO2 max tests that the performer will only use up to 75 or to 80% of their heart rate. The direct method of measuring is the gas analysis VO2 max test, using a computer to calculate the results. This is because there are fewer opportunities for human error to occur, and instead uses reliable and valid equipment to help calculate the results. The gas analysis is a graded exercise test. The exercise intensity is progressively increased while measuring ventilation and oxygen and carbon dioxide concentrations of the inhaled and exhaled air. The indirect method of VO2 max tests, which can be both maximal or submaximal, are Pearson's VO2 max is predicted by the measurements taken. This is usually heart rate. Examples of indirect VO2 max tests are the multi-stage fitness test, yo-yo test, and the Cooper 12-minute run, which are all maximal VO2 tests. Whereas the Chester step test, Queen step test, and Harvard step test are all submaximal VO2 tests. Literature review. This literature looks at the Queen College step test predicted the VO2 max This test was conducted by Shamsi et al. February 2011, which was sports science professors at the Islamic Azad University in Iran. The purpose of the study was to elevate the relative relation between stature and maximal oxygen uptake. 54 active female university students with a mean age of 23.2 to 22, with a height of 162.13 and a weight of 57.92 kilograms, with their body mass index being 22.3 kilograms and fat-free mass being 43.75 kilograms. They assessed the VO2 max by using the Queen's College step test and the cycle ergometer test. They were divided into 3 groups, including short, medium and high statures. The results indicated that the VO2 max values measured by using the Queen's College step test and cycle ergometer were significantly different. However, the difference between the VO2 max values, which were directly measured by cycle ergometer and indirectly predicted by the Queen's College step test within each 3 groups, were significantly insignificant, with a p-value greater than 0.05. Within each 3 groups, the Queen's College step test measured VO2 max values were higher than the VO2 max values measured by the psychoergometer. In addition, there was no significant statistical correlation between stature and VO2 max measurements in all participants. This test is a reliable test as it was conducted by professors of sports and exercise scientists who have studied the science of human body for a very long period of time, meaning they have a lot of knowledge on what they are talking about. This test is also considered to be very reliable because the research was conducted in 2011, which is only a few years ago, meaning the research they collected was up to date and they were using the correct methods to calculate the results. Method: Queen's College step-up test. To set up the Queen's College step test, the participants first has to fill out an informed consent, identifying they know what will happen in the test, procedures and how the test will go. The researcher will also fill out a risk assessment before undergoing the test to prevent any possible injuries from occurring, and it informs the researcher how to deal with any injuries that come up. Next, the researcher asks the participants to stand in front of a bench or seat which is 41.3 centimeters high. The researcher uses a recording or video of the beeps the participants have to keep up to, which is on a CD. This will tell them how fast they should go, as they will need to keep up with the beat. Then the researcher needs an assistant who isn't taking part in the test to record the 3 minutes of them stepping up and down and the 15 seconds of them recording their heart rate after they've done the 3 minutes. Once everyone is ready and all the equipment is set up, the researcher can start the test. On the recording or video, there will be a short explanation of what they should do and when it will begin. When the participants have finished the step-ups, the timer tells the participants to find their pulse. Once they have found it, they have to time it for 15 seconds and count their heartbeat. The results they got in the 15 seconds is multiplied by 4 to give them their heart rate for a minute. Then, using the equation and online calculator such as the VO2 calculator, work out the participants' cardiorespiratory fitness levels and heart rate, which will provide the participants' VO2 max scores. For a male, the equation is milliliter divided by kilogram divided by minutes equals 111.33. Take away 0.42 times heart rate. And for females, it's milliliters divided by kilograms divided by min equals 65.81. Take away open brackets 0.1847 times heart rate, close brackets. Multi-stage fitness test. To do the multi-stage fitness test, the participant will have to fill out an informed consent form, Part Q, and the researcher will have to fill out a risk assessment. The reason for these requirements are that the participant has to know what they are getting themselves into before they carry out the test, and the researcher has to do a risk assessment to prevent any possible injuries occurring, and must have a knowledge of what to do if these injuries do occur. Next, the researcher measures out 30 meters for the participants to run. The researcher must make sure the surface isn't slippery or has water on it. He also needs to have a multi-stage fitness test audio tape or CD so that the participants can regulate their speed. There also needs to be an assistant recording each stage. If someone drops out, as this will help the participant, as they don't have to remember what their score is each time they run. The participant have to start on the cones, and the researcher will start the CD. Once all the participants are ready, then they run to the other side once the first beep went. When they reach the other side, they would wait for the second beep, which tells them to run back, and so on. The assistant has to keep track of which levels the recording is on, so he knows when each participant drops out. Results for the multi-stage fitness test. When looking at the results for the multi-stage fitness test for one athlete's set of results, we can see that the participant U has a relative VO2 max score of 33.6, getting to level 6.2. When comparing these to the normative data for an 18-year-old male on the level tables, we can see that participant U was just below average or poor with a score of 33.6. Using this data we can compare it to the average multi-stage fitness test scores from athletes in their sport. Participant U takes part in football. Looking at a study